All right, y'all, here we go. This is going to be information you need to know so you can be ready for your Unit 1 test. So, it's going to be in no particular order. Know that you can go back over all lectures and information Quizlets that have been released. So these are the things in, again, no particular order that you need to know. Remember that 90% of stars are in the main sequence. So when you're looking at supergiants up at the top, the real bright ones, and then giants, and the dimmer but warmer white dwarfs, just know that that only makes up about 10% of all the stars in the whole entire universe. So most stars, most of them, are in their main sequence. And that when you're looking at the HR diagram, that as you move higher on the HR diagram, the brighter it gets. From the right to the left on the HR diagram, the temperature increases. And also know that their spectral class and temperature, they kind of line up together. So all the stars in G, for example, spectral class G, are around the same types of temperatures. So, and then remember that brightness can also be called absolute magnitude and luminosity. So stars are categorized by their temperature and brightness, and that stars are spheres of matter with temperature and density strong enough to create a nuclear reaction at its core. And that nuclear reaction is converting H to He. So definitely remember that. Nebulas are made up of clouds of dust and gas, and they are the birthplace of stars. And that nebulas are inside of galaxies. There's tons of nebulas inside of galaxies. And our galaxy is the Milky Way galaxy, and it's also described as pinwheel and spiral, disc-shaped. And we are inside of it, so we really can't see the entire shape of the galaxy. We would have to get outside of it to really know. But it's through the use of telescopes that we can look at other galaxies and put that idea together of what ours looks like. And we believe that it looks like a spiral galaxies, because galaxies are characterized by their shape. And our solar system is down one of the spiral arms of our Milky Way galaxy, so about halfway down the spiral arm of the Milky Way galaxy. And the sun is in the middle of the solar system. So just make sure you can kind of understand all that. There are a couple other different types of galaxies. Irregular, doesn't really have a shape, and elliptical, looks like an egg kind of, or a football, big old fat football. That's the shape of the elliptical galaxy. Know that the sun is the closest star to us. The next star is really far away. And in fact, when we look up at the sky, it would just be a dot in the sky at night. We wouldn't even see it. It would so far away that it doesn't give us daylight. There's only one star that does that, our sun. And the reason why is because it's so close. Our sun is an average star. It's an average star halfway through its life cycle, and it will not explode. It will not supernova because it's not a massive star. It's eventually going to become a red giant and then shed its outer layers, becoming a white dwarf and then black dwarf. Remember, you got no swag, so please move. And that is the universe, galaxy, nebula, solar system, star, planet, moon, and that's from greatest mass to least. You're going to need to do it backwards as well. So as you guys have seen, sometimes the question asks from smallest to largest. So just be aware. Remember that a light year is the distance that light travels in a year. And the reason why we use that is because distances in space are so vast. And remember that space is made up mostly of empty space. Universe is made up of empty space. And there's just a lot of distance between stars. Let's look at the EM spectrum. Remember that as you are looking at the EM spectrum, that you have radio waves which are low frequency, low energy, and then you have gamma on the other side of it, which is high frequency, high energy waves. They're the smallest wave. They're super small, about the size of a nucleus of an atom, whereas radio waves are really, really large. And the larger the wave is, the less harm it does to humans. The smaller it gets, the worse off it is. Like X-rays, not good for us. That's why you want to minimize how much X-ray you get in your life. Remember, everything in space moves counterclockwise. That's always important to know. And then we're going to finish off with a couple other things. Let's talk about seasons. That as you are looking at seasons, you need to remember that the first thing I do is find the northern hemisphere, and that's the one on top, and find it tilted towards the sun, and we can identify that as summer. And you need to know the order of the seasons, so it goes summer, fall, winter, and spring. So knowing those, and then whatever is happening in the southern hemisphere, that it is the opposite. Really important that you have that nailed. Remember that rotation is spinning, and it's responsible for day and night on Earth, and revolution is orbiting, going around. It takes 365 days for, the Earth to orbit the sun. But you need revolution and tilt to give us seasons. Those are two really key things that you need to know. Remember that the warmest area on Earth is the band right around the equator. That's where the warmth happens for the most part, and it's because it's typically tilted towards the sun, and the equator doesn't really have a great change in season. So it's really warm. But as convection cycles, that warmth is distributed away from the equator. So we're talking about warm water distributed away from the equator and warm air distributed away from the equator. And that just kind of makes our Earth definitely more habitable and comfortable, because because of convection currents, this air and this energy being distributed all around the globe. And my friends, that is what you need to know for your first unit test. Make sure you study. Good luck.